According to the Newton's second law, we know that when a body of different mass is kept and acted by a same amount of force, their magnitudes are always equal. Hello students, today the class of Newton's second law of motion, न्यूटन के गति के दूसरे नियम को हम लोग पढ़ने जा रहे हैं, जिसमें आप लोगों ने देखा कि हम न्यूटन्स फर्स्ट लॉ ऑफ मोशन को डिराइव किए और उससे जो जानकारियाँ आपको मिले दैट हेल्प यू इन दिस सेकेंड लॉ. अकॉर्डिंग टू न्यूटन्स सेकेंड लॉ ऑफ मोशन, we know that when two bodies, a heavy one and a light one, are acted by the same amount of force in a same direction at the same times. The lighter one get high speed or velocity, whereas heavier one get lesser than the first, means lighter object. But hence according to second law of motion, we are coming to the laws. The rate of change of momentum of a body is directly proportional to the applied force, and object can take place in the same direction in which object is displaced. Again, I am coming to express the second law of motion, that is the rate of change of momentum or impulse of force of a body is directly proportional to the applied force and takes place in the direction in which force is act. According to this definition, it clear about force is directly proportional to the change in momentum upon time. This is according to the second law of motion. Consider two bodies are kept on a same surface at point A and point B. The mass of object is m and their initial velocity is u and final velocity is v. If force F is act on the body at point A, its momentum is P1 and their momentum become p2. Let the displacement or distance traveled by the object is d within the time period t second. Consider when F force is act at point A. Force F act on point A. Therefore, initial velocity is u. Initial momentum, that is p1, is mu after acting F force. The body of mass m displaced point A to point B, then due to the force, final velocity is v arrow, and final momentum is mv. In this way, the velocity of the object become u to v, a point to b point, and their momentum become p1 to p2 due to acting of F force within the time period t second. Therefore, change in momentum from A to B of the object. Now, I am coming to know about the second law of Newton's change in momentum due to force P equal to P2 minus P1. Therefore, momentum equal to mv minus mu, that is final momentum minus initial momentum, that is mv minus mu. Body displaced A to B by the displacement d within the time period t second, hence change in the rate of change in momentum change in momentum explain P upon T, that is P2 minus P1 upon T. Rate of change in momentum is directly proportional to the applied force, means it gradually explain P upon T equal to F. Therefore, we may write here the change in momentum is directly proportional to the applied force, hence F vary as P2 minus P1 by T, or F vary as mv minus mu upon T, or F vary as mv minus u upon T. We know that acceleration of a body is the rate of change in velocity. Therefore v minus u upon T is acceleration. Hence, we may write here F vary as ma. This qualifies the second law of motion according to the laws, that is stated as the rate of change in momentum of a body is directly proportional to the applied force, and it takes place in the direction in which force is act. Means the magnitude of force is as equivalent, as similar as the product of mass and the acceleration of a body. If we explain it in another form, then one should have retained it, or one should have derived it in the same manner, that is F equal to kma, where k is constant and k बराबर 1 in air. Therefore, F equal to ma, that qualify the definition of a force of a body. According to this experiment, we define it. A force is the product of a body of their mass and their acceleration, and it may also define as force is a physical quantity that is directly proportional to the rate of change in momentum or rate of change in impulse, and displacement of object is in the same direction in which force is acting. That is the second law of motion. Here, second law of motion also measuring the force in terms of their mass and acceleration. कहने का मतलब है कि हम फोर्स के द्वारा किसी ऑब्जेक्ट के मास और उसके एक्सीलरेशन के द्वारा माप सकते हैं। देयरफॉर m इक्वल टू f अपॉन a, फोर्स अपॉन एक्सीलरेशन, और a इक्वल टू फोर्स अपॉन मास। Here these two, first and second, can be defined as mass of a body is the acting force, is the ratio of acting force and rising acceleration, and second equation is also defined as the ratio of force and mass of a body is equivalent to acceleration. According to SI unit, K is kg meter per second, that is equal to per second square, that is equal to 1n. In CGS, the unit of force is 10 to the power 5 gram cm per second square, that is 10 to the power 5 dyne. Force always explain about the direction of movement of the object from a point to another point. So the force is a vector physical quantity. Now tomorrow I am coming to study about the third law of motion. The laws of motion given by the Newton are always in our lifestyle accident. It is found everywhere, in every step and every movement. The third law, second law and first law are created in front of myself, yourself and any other person. Thanking you. Now the special notice to you that if the plan of second law of motion is very effective, very genius to the all student and viewer, it type of study and model of study is much better and that interpret you, then आप कम से कम इस क्लास को सब्सक्राइब करें, लाइक करें और देयर आफ्टर आप इसे शेयर भी कर सकते हैं। इसी उम्मीद के साथ मैं कल फिर आपसे थर्ड लॉ ऑफ मोशन में मिलूँगा। थैंक यू।